Alright, so good day. Not a cheeky video today, just a little bit of a let's work through that problem that I threw at you on Friday. So, for the few of us that actually responded, I gave you the problem of there's 26 of us, including myself, in our discrete math class this semester. Whether or not you remember anybody else, there actually were 26 of us that occupied our room back the last time that we were all together. Now, what is the probability that at least two of us share a birthday? Well, there's 365 days in a year. That's 26 birthdays, 365 days total. Should be pretty small, maybe 26 out of 365. And I gave you the kind of comparing it to coin flips. More likely than flipping one coin and guessing it correctly. About flipping two coins and guessing both of them correctly. Flipping three coins, flipping all three heads, etc. But let's go and work it out. What is the probability that at least two of us share a birthday? Now, the problem with this is that we would need to think about every single possibility that two of us share a birthday. So you and me share a birthday, me and that person that sat next to you share a birthday, me and that other person, the two of you that sit next to each other, you share a birthday, or three people share a birthday, four people share a birthday. We would have to do every single possible combination out of the 26, putting all that together. Yikes, I don't want to do that. There's a loophole here. I have this idea, at least two of us share a birthday. Well, that at least, that cues us in. We're going to think about the opposite, the complement. Let's instead find the probability that nobody shares a birthday. This reminds us of those complementary events. Now, remember, the probability of some event is 1 subtract the probability that something does not happen. So if we're looking for the probability that someone, at least two people share a birthday, that's the opposite of nobody shares a birthday. So we're going to do 1 minus the probability nobody shares a birthday is going to give us that somebody shares a birthday. So breaking this apart, as I just said, the probability that someone shares a birthday will be 1 minus the probability that nobody shares a birthday. Let's see what happens. Look for a pattern, see if we can shorten this up. So, I'm by myself. Yep, I'm used to it at this point. I think I made a video at some point and joked about being quarantined for 83 days. Yeah, we're getting close to that. The 13th was officially 2 months. Yeah, here we are. It's rough. I'm talking to the hair on my head, trying to give it a pep talk, saying, you can grow, little guys, by the time we get back to school. No more stress. We got this. Anyways, I'm by myself. What's the probability that nobody shares my birthday? Well, obviously, nobody shares my birthday. It's 100% because it's only me. There's 365 days available for me to have a birthday out of 365 days. Friend number 1 shows up. What's the probability that they have a different birthday? Remember, we're going for nobody shares a birthday. So we want I have a different birthday, the next person has a different birthday, the next person has a different birthday. Well, I already have a birthday, so that's 1 day out of the year that's already taken. That means there are 364 days out of 365 days that our friend number 1 can have a birthday. Friend number 2 shows up. What's the probability they have a different birthday? Well, taking 1 birthday away from me, taking 1 birthday away from my first friend, friend 2, there's 1 less day. There's only 363 days available for them to have a different birthday out of the total. And so forth. Friend number 3 shows up. There's going to be 362 options for them out of 365. Look at what happens to the numerator. Look at what happens to the denominator. We're going to do this 26 times. Well, can we shorten this up? Well, 26 of us, probability that nobody shares a birthday is the product that everybody is different. So we would say probability that everybody is different, well, there's me, 365 over 365. Friend number 1 shows up, 364. Friend number 2, 363. Friend number 4, number 3, 362. All the way, 26 times. Well, 365 times 364 times 363 times 362 times all the way down, we're repeating. That's a permutation. Now notice the denominator is always the same. We're going to do this 26 times. 26 times. So this is actually shorthand 365p26. Using our factorial notation, it's multiplied 26 values. Our denominator is 365 raised to the 26 because we're multiplying that 26 different times. We want the probability that somebody shares a birthday, so it's going to be 1 minus the probability that nobody shares a birthday. So it's going to be 1 minus what we just found above. I'm going to go into the calculator to type this in. Now, I neglected to show this to you earlier, but we can actually do NPR, NCR in the calculator. We can do that in here. So we're going to have 1 minus, I'm going to type in, I'm going to put in parentheses, 365. Our NPR, NCR, our permutations and combinations, it's under the math button. We go math, over to prob, and we've got number 2 and number 3. Notice number 4, there's our factorial. We've got NPR. Now my calculator shows up with the notation. Yours might just say NPR. It works the same. We've got 26 divided by 365 raised to the 26th power. If you type this into your calculator separately, it's going to give you an error overflow because you're going to do 365 to the 26th power. That is a massive number. But okay, let's work this out. In a moment, I'm going to hit enter. We're going to see really how unlikely this is, how small it is that at least 2 of us share a birthday. So, you ready? I'm going to hit enter. If you don't want me to hit enter, you actually have to pause the video, skip forward, just, well, don't pay attention like usual, and you won't get the result. All right, I'm going. Hitting enter. Here we go. Last chance. What? 0.598? That's a 60% chance that 2 of us share a birthday. That's wild. You've got a better success rate of 2 of us sharing a birthday than flipping a coin and guessing heads or tails. That's wild. Or nope, I mean, that's crazy is what was typed there. But that's the way it actually works out. This is something that's known as the birthday paradox. Given even a relatively small group, 26 of us, is actually a decent size probability that 2 of us share a birthday. Just having 23 people in a room, 23 people is enough to get it to be 50%. And it keeps on increasing, obviously, with more people that you have. So, here's the task. Usually, this is the time when we start going around the classroom and I say, hey, what's your birthday? And we write it up on the board until we get a repeat. My birthday is middle of the summer, not middle of the summer, end of July. I'll put that up there in the comments, but usually at this time we start going around the classroom asking everybody, and then when it doesn't work out, we yell at people in the hallway until we get enough people, blah, 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 blah. So we don't have that. We do have a comments section for Google Classroom. What I'm asking? Post your birthday in the Google Classroom comments. I'll list mine up there. It's the 30th of July. Remember that this summer when you're bored sitting at home, I'm doing the same thing. This is the first summer actually in 22 years that I don't know what I'm doing. My summer camp was canceled. My summer job, I'm on the dock for right now. Anyways, post your birthday in the Google Classroom comments. We'll see, do 2 of us or more share a birthday. Take it easy.